Hello everyone, my name is Keith Snyder and I'm going to give a brief introduction of Team 16's project and then discuss fast Fourier transforms and how they apply to the product we're designing. Next, Brandon is going to talk about current signatures of different appliances when they start up and how we plan to use some of that data in our device. Then Eric will discuss user interfaces and how the end user might interact with our device. And finally, Zach is going to talk about the different applications of our product and then wrap it up with a few concluding remarks and an update on our product progress. Now, SCADA stands for Smart Current Acquisition and Data Analysis. The concept is that this will be a low-cost, easy-to-install power monitoring device that a residential user can install on their home's breaker panel to get a better idea of their power usage habits. A current transformer will be placed on each of the two service entry conductors in the breaker panel, and by analyzing the current both in the time domain by looking at start signatures and in the frequency domain by sampling and running FFTs in real time, the device will be able to tell when a new appliance has turned on, save that appliance's unique signature, and recognize when it turns on and off in the future. By doing this, it will be able to generate reports of the user's total power consumption, as well as power consumption by each appliance, so that users will have a better idea of what they're spending their money on when they pay their utility bill. One of the ways we plan to identify appliances with our device is by looking at the current waveform in the frequency domain. A waveform can be quickly converted from the time domain to the frequency domain using an algorithm that was developed in 1965 by Cooley and Tukey called the fast Fourier transform. As you can see here, we've used a wave generator to generate first a pure sine wave at 50 Hz and then used an Arduino to run an FFT on the signal. The resulting plot has one large peak associated with just that frequency. In the second plot down here, we've combined a 50 Hz sine wave and a 20 Hz sine wave. And in the resulting plot in the frequency domain, you can see multiple peaks at different frequencies. So real-world testing on different appliances in our home supports the theory that this may be a valid way of automating appliance recognition. This demonstration shows the current plot for each of the home's two split phases in the time domain on the left and frequency domain on the right. The first thing you'll notice when I play the video is that I turn on a toaster and the amplitude on the blue sine wave here gets larger, but it's more or less the same shape. Now this is accompanied by a spike in the 60 Hertz frequency on the plot on the right, which you would be able to see, but we've cropped the axis here so that you can better see the subsequent harmonics, which are much lower in relative magnitude to the 60 Hertz frequency. So the next thing that happens is I turn on a microwave, and you'll notice that the shape of this blue wave here changes. Now, that unique shape of the blue wave is going to be accompanied by these even number harmonics that were almost non-existent before. So when the microwave turns off, then you'll notice that they disappear. And then finally, the toaster will turn off, and this goes back to the baseline. So our plan is to develop a prototype that when it detects an increase in current can filter out the prior existing harmonics, look at the net change to identify appliances by their unique harmonic signature. Now I'll turn it over to Brandon, who's going to talk about identification by start signatures. Thank you.
Okay, this is the time domain signature part of our SCADA project. I'm just going to go through, try to do it quickly. What we've got the air conditioner and how it starts up. This is sort of how we feel like we can predict what is on when it comes on based on the signature that it makes when it starts. So you can see here we've got the spike in amplitude on one phase and not so much on the other phase. It's a little less there. And then it kind of tapers off and then kind of just runs after that. So you can see the compressor part of the air conditioner settles out and it has came up to speed and is running. Same thing with the fan on the inside of the house. So that's kind of how we see the air conditioner. It's pretty constant, 6 times it did the same thing. So we can kind of feel like we can say anytime that happens, the air conditioner is kicked on. And then we come down here to the well. You can see it's something similar. It spikes up. One thing that you can kind of see is that the well, it seems that the where it runs is varies a little bit, and the reason for that is what is on when it kicks on. So when the air conditioner kicked on, there's really nothing else on except for your normal loads of lights and stuff like that. Well, whenever the well kicked on, sometimes we had quite a load, and sometimes we didn't. So you can see here, this is probably when the water heater was on, and then Other ones might be where nothing was on. So brings me into my next slide here, where you can see over time it gets quite messy with everything that kicks on. This is, around bedtime where kids are uh, running appliances and stuff, the well and the water heater going to bed. So you can see how they all overlap and kind of make a mess. So here we got the well kicks on, and then some other single phase load kicks on here, all the while the water heater is already on. And then the air conditioner kicks on and runs for a while and kicks off. Then the water heater stays running. Then the well kicks back on. And then while the well is on, then the water heater kicks off, and then the well kicks off. Then you've got your normal loads, and then the air conditioner kicks on, and so on and so forth throughout the rest of this, the two currents phases that we have here. And so you can kind of see what's going on here, how it's kind of messy, but we intend to be able to clean this up or not clean it up, but kind of look at it and say, what we think is on, and try to provide some sort of feedback as to what's going on, just based on the two currents coming into the house.
Thanks, Brandon. The user interface for the SCADA project can be broken up into 3 parts. First, we'll have a simple local UI at the device involving the use of an LCD screen like the one pictured here. Some type of input device like a rotary encoder will toggle the information on the screen. This will be used to view live data and possibly for debugging or fault finding purposes. Next, a web-based UI that shows in real time the appliances that are currently running and how much power they are using. With this data, we can then show how much money it is costing to run a specific appliance or all the appliances put together. And lastly, a mobile device UI will help make the SCADA a truly Internet of Things device by being able to view data and control the device from anywhere in the world. The top 3 pictures here are screenshots of monitoring data from cell phones. The picture on the left is a power spike visualized when I turn on my electric stove and then off, viewed in real time. The method of realizing the web and mobile UI is yet to be fully determined, and in part will depend on what hardware we decide to use for the final product. Should we go with the Arduino Duo, we have done some testing making the device a web server and outputting the data using HTML commands. Should we go with the Particle Photon, we have access to Particle's cloud, which is both secure and highly customizable. Some data displayed on the Particle cloud is pictured on the bottom half of this slide. No matter what hardware interface we choose, the goals of the user interface remains the same: to be clear and accurate, easy to use, and accessible from any device. I'll now pass you off to Zach, who will discuss the application and use of the SCADA device. Thank you.
Thanks, Eric. The SCADA team sees the application for this technology from a couple of different perspectives. Power companies could provide better customer support through things like itemized billing, letting people know how much they're spending per appliance each month, or smart grid operations. Perhaps in the future somebody invents a smart breaker that allows power companies to shed non-vital loads on a breaker-by-breaker basis while maintaining vital load operation during brownouts. Instead of losing entire portions of a grid, we lose pieces of a house. From the consumer perspective, being able to monitor your power consumption in real time at an equipment specific level should be able to motivate people or give people the opportunity to reduce their power consumption by operating their appliances more efficiently. We all know to turn the temperature on a thermostat up in the summer. When you see how much money you're spending on your water heater, which is surprising, you'll be motivated to turn it up a couple degrees, or maybe operate your washer and dryer on the efficient mode. And also through smart purchasing decisions, having that information on how much money you're spending on your dishwasher may motivate people to buy more efficient options in the future. So in summary, the SCADA team is on track. We're prototyping on multiple platforms. We're going to continue to do that until selection is made at the end of the semester. We could turn in a prototype right now. We're kind of agnostic to what the hardware is. There are a lot of options out there, but the heart of our technology is functional. The software works, and we're going to keep exploring options to become more efficient, reduce costs, simplify the design, and other aspects in 489. We're looking at going to the cloud. We're checking out cloud technologies. That's just another one of these options that we get to look at. It's a very fast-paced project, very fluid. New ideas are explored very quickly, and we employ those introduction to engineering philosophies that were taught to us about fail early and fail often. We've really enjoyed this project. We think it's really interesting. We hope you enjoy it as much as we have. Thank you.